So we all know how the 9800X3D performs under some of the best case scenarios, but it got me thinking, how would this chip perform in a small form factor gaming rig? I think you're going to be very surprised by these results. So in this video, I'm going to start off by going over the actual specs of the rig that I used and compare and contrast with the open air test bench that we use for most of the testing. But then I actually want to bring up some of the tests here in real time so you can kind of watch the heat and the power draw and that kind of stuff under some different kinds of scenarios. But then I want to finish off with some surprise numbers, because I know you like charts. Don't worry, I've got charts, but I'm not going to get to them quite yet because it's going to be very juicy and very revealing. So before we get to the testing, I'm very excited about this. Let's stop for a minute and go over the specifications of both of the rigs. Usually, benchmarking best practices is that you want to keep as many things equal as possible, but that's not really what we're testing here. We are testing what a full tower open bench setup and how it's going to compare to a mini ITX system. So unfortunately, the only thing I was able to reuse was the CPU itself. Inside of the full tower, the motherboard is an Asus ROG Crosshair X870E Hero. It's got an MSI RTX 4090 Gaming X Trio, 32 gigabytes of DDR5 Patriot Viper Venom DRAM, and it was tuned to 6,000 megatransfers per second. The SSD is a Crucial T700 2 terabyte. The cooler is a Corsair H150i, which is a 360 millimeter AIO, and a 1200 watt power supply supplied by Silverstone. Now this is once again all in a full ATX case, but all the panels are off, full maximum cooling on all the fans, so this is meant to be pretty much an open air test bench. But we're not getting that here with this mini ITX system. This case is a Fractal Design Terra, and inside I've got an Asus ROG Strix X870E-I gaming Wi-Fi mini ITX motherboard. The GPU is also a GeForce RTX 4090, but is a Founders Edition because that's all that could fit in here. The power supply is also from Silverstone, but it's only 850 watt, but it is also platinum just like the other one. And last but not least is the cooler itself. This low profile cooler is an ID Cooling IS55, and I swapped out the included fan with a Be Quiet fan, so it's a little better performant and a little quieter. The DRAM has the same capacity and the same speed, but these sticks are low profile and they are G.Skill Flare X5. The SSD is a Solidigm P44 Pro, also 2 terabyte. Now I know this isn't the worst case scenario in terms of mini ITX. This is actually a pretty damn good mini ITX case, but this is what I've actually been using for the last year. So rather than try to rebuild something, it was easy for me to just take what I've been using off the shelf. And with all that said, let's get into the testing. All right, so let's start off by showing some easy scenarios. On the left screen here, I have a Rainbow Six Siege up. Set to 1080p with really low quality to try to do as much CPU bottlenecking as we can. But on these screens, I've got the hardware monitor up so we can watch in real time both the temperature, the package power, and the clocks of the 9800X3D, as well as the temperature and power draw of the 4090 that's in here. So let's go ahead and kick up the benchmark run for the game. All right, so we got the benchmark running over here. We can see the utilization over on Task Manager. Now let's look at the details on hardware monitor. The package temperature right now is hovering around 76C. The package power is drawing, mid 80 watts. And if we look at those clocks, it's holding pretty steady at 5.2. So not too bad so far. We can even see at some point it even boosted to 5.3. On all of these cores, well, all of them but one. Looking down at the 4090, we can see it's actually not getting too hot here. We are trying to stress test the CPU, give as much bottleneck as we can, and it's only pulling around 180-ish watts on this, so let's let this finish and kind of see where we land. So we're actually going to ignore the score here because I'm not officially testing this, so we'll look at the numbers later. But we can confirm that as much as possible, we're putting a load onto the CPU to try to really max it out. But under this workload, we saw that, I mean, you know, the temperatures, the clocks held pretty steady the whole time. So this wasn't too bad for the chip. All right, so the next easy kind of test case that I have set up is here with F1 2023. I'm going to go into the options, get into the graphical settings, and run the benchmark. All right, so we have the F1 benchmark running. Just like Siege, I'm running at 1080p with the lowest preset possible to try to really put a CPU bottleneck on the system. And if we look over at Task Manager, you can see that we are loading up almost every single core of the system. Let's check out the hardware monitor. It's reporting that the package temperature right now is holding around, you know, kind of mid-high 70s. I saw it creeping up a little bit, but it's, yeah, somewhere around 76, 77, mid to high 70s is what I'm going to say it's kind of holding at. The package power is reporting 85, 86, so kind of mid 80s. So it dropped down a little bit. I guess it depends on the scene. And when we look at clocks, we're sitting here at 5.2. Oh, you just saw it drop down to 5.0. But it's mostly holding steady at 5.2 across every single clock or every single CPU core here. Let's look at the GPU. The GPU is running at a nice lukewarm temperature of 54 C, so it's not spitting a ton of hot air into the system. And the package power is hovering once again around 180. Looking at the total system power, we're pretty much over 350, not quite hitting 400. Somewhere around there, so you know we're not putting too much stress on the system yet. So for this next test, I'm going to use Cyberpunk 2077. I'm going to do something a little bit different. I'm actually going to force a GPU bottleneck by running in full path tracing mode, 4K, all the bells and whistles, to see you know what the CPU is going to be sitting there doing while it's waiting for the GPU to render all these frames. All right, we got the benchmark running. We can see over here in Task Manager that the CPU, you know, is kind of snoozing a little bit. It's definitely not under a lot of load, and we can see that the GPU we're pushing 70C. And then 400 watts on the GPU, so we're forcing all of the load onto the GPU, which means that the actual CPU is kind of just snoozing. It's just sitting there in the high 60s, you know, not doing much. I mean, even the package power, it's like, what, 50, you know, low to mid 50s. And some of these clocks are dropping down to 4.6, but it's mostly holding at 5.2. And to be honest, this is kind of more the scenario that I would be playing it at home. I'm going to, you know, be putting more load on the GPU than the CPU. So this is kind of an interesting data point. So now let's do the reverse and put the bottleneck back on the CPU by putting it in 1080p with a very low preset and kind of see what the CPU is going to do under that load. So with these settings, we can see we're definitely forcing more of a CPU bottleneck in this scenario. The GPU is not even being fully utilized here, and because of that, oh boy! All right, we're really getting dangerously into that TJ Maxx territory. You know, low 90s. It quite hasn't hit yet, not yet, and we're pulling around 110 watts. Looks like we're dropping down some of these clocks to 5.1. I mean, we still get some 5.2s here and there, but 5.1 is kind of more where it's sitting. So this is definitely really stressing that CPU. And oh, there we go. We hit a TJ Maxx. This is definitely stressing it out. But once again, this is kind of not necessarily a real world use case, but it's interesting to kind of see the results. So that was gaming scenarios, and I do promise that I have official benchmark numbers. We're going to get to the numbers later. We're going to get to the numbers later. You definitely want to see these numbers. But next up, let's use some synthetic benchmarks to really start to stress the system to the absolute edge. And this is where things get really interesting. So first up, I'm going to use 3D Mark's Time Spy Extreme. to kind of stress both the CPU and GPU in different ways. So one of the things I like about Temps by Extreme is that not only does it give you a nice handy dandy score, it actually does monitor stuff in real time. So if we go down here, we've got the frame rate, sure, whatever, but let's look at temperatures. So the actual blue line here is the GPU temperature. Those first two tests are stressing the GPU more than the CPU. You can kind of see that the CPU is just holding steady. And funny enough, they're kind of sitting here at the same kind of temperature. I mean, obviously it takes a minute for the GPU to warm up, but through both these tests, it's kind of equal, around 70 C, which is funny. And then we get to the actual CPU test, and that's where you can see the GPU starts to cool off, and the CPU is pretty much hitting TJ max throughout the duration of the test. And more importantly, let's actually look down here at the frequency. And what we're looking for here is the actual CPU clock frequency. So during these first two tests on this purple line, you can see the CPU is pretty much holding at 5.2, but also surprisingly enough, when you get over to that CPU test, I mean, it dips down a little bit to 5.1, but for the most part, it is sitting there holding at 5.2 through the duration of this whole kind of test. So I think that's actually pretty good. Okay, enough messing around. Let's stress the hell out of the system. And when I think of stress testing a CPU, I start to think of Cinebench. So what I have up right now is a Cinebench all-core workload running here in the background. Obviously the GPU is sitting idle and not doing anything, but we're going to start to see this thing's just sitting here at TJ max. Obviously we know that the CPU is meant to do that. It is meant to use as much of the system as possible to get as much performance. But yeah, we're stressing the hell out of this. And when we look at the clocks, we can see that no longer are we sitting there at 5.2. We're pretty much at like 4.8, 4.9. I'm sure if we let this go for like 10 more minutes, we'll probably drop down to like 4.7. But we are throttling under this situation. Let's not stop there. Let's go ahead and fire up Furmark, which is a GPU stress test, and really warm up this system and see what's going on here. So on one side, we got Furmark going on. On this side, we got a multi-core Cinebench workload going on. So we already knew that we were maxing out to the TJ max on the CPU. We are indeed pulling around 120-ish watts. And here on the clocks, yeah, we're starting to see some dips down into 4.7 territory. But you know, it's kind of ping-ponging between 4.8, even a couple 5.0 still. But we look down here at the GPU, and yeah, we are pulling almost 450 watts with this Furmark test. It is not quite heated up as much, so let's wait for a second. All right, so this has been running for a little bit over 10 minutes now, and we can confirm, guess what? The package temperature on the CPU is still at TJ max. You know, it's not throttled too much on the power. It's still putting out power. Oh boy, look at these clocks. 4.6, 4.7, 4.8, 4.9. You know, but it's I'm not really seeing any 5.0s anymore. This is definitely getting pretty toasty. Let's look down at the GPU. 82C. I can confirm that it's toasty, and it is still pulling a whopping 450 watts. But you know what? I have teased it for far too long. This is fun. This is fun, but it doesn't matter. Let's get to the numbers. How does this all affect the numbers? And let's start with some numbers here in Cinebench 2024 multi-core workloads, shall we? Right here, I have the number, the official score for the 9800X3D on a 360mm AIO is 1315. The official Cinebench score for the same chip in the small form factor rig without Furmark, mind you, is, boom, 1299. Now we're talking about a score that's not too far off. But we're not done with the numbers yet. Let's throw up the 7800X3D on a 360mm AIO. We kind of already knew this. This was in the official review here. But now, for the grand finale, let's see what the all-core workload score was while Furmark was running in the background under this same exact scenario. Check this out. it turned in a score of 1198. Ladies and gentlemen, not only is that faster than the 7800X3D on a 360mm AIO, that is within spitting distance. I'm not great at math, but the math tells me that's about 9% off. So what I'm telling you is that literally stressing this system to the absolute max it is within spitting distance of the same CPU running in a full tower. That is nuts. That is nuts. Okay, drama aside, I'm actually going to stop this test because it's getting a little toasty in here, and I'm going to bring up some numbers. We're going to go over some more numbers. All right, so now let's get to the rest of the benchmark numbers because I know I tease them and I know you love seeing bigger bar better. I will say that all the numbers that are not in the small form factor were taken from the initial review in our test bench, and so there are slight variations to BIOS numbering and things like that, but it didn't really seem to make much of a difference, and really we're just talking about a general indication here. Also, I included the numbers for the 7800X3D just to compare and contrast to see how that chip also did in both scenarios, and just for shits and giggles, I threw in an Intel result as well in case you're interested. Let's start off with Cinebench single core, which is lightly threaded, and surprise, surprise, there's not much of a difference between the 360mm AIO and the small form factor system. So really, let's move over to results that are going to push all of the cores and really try to show off how the differences of cooling in these two systems is going to affect all core workloads. And looking at these results, that's not bad. That is within spitting distance. Obviously, we saw the Cinebench results earlier, but when looking at things like Blender or Handbrake, we are still within spitting distance of the same chip on a 360mm AIO, which honestly surprised me, and I think you're gonna be pretty surprised as well. These are particularly good numbers and shows just how resilient this chip is, regardless of cooling. Moving over to mixed kind of workloads in Premiere and Photoshop, and we see, yeah, it's depressed a little bit in something like Premiere, but for the most part, once again, it's still within spitting distance and still not what I would have expected for the difference between the cooler sizes. And moving over to some more GPU-limited workloads, we see that, yeah, there's not much of a difference between the two, though we are starting to see just a little bit of a dip on that 9800X3D in the Cyberpunk test as I did it here. And really where the big losses are the rest of the games which push a real high frame rates and can be a little bit more CPU intensive under these testing scenarios that I had here. Unfortunately, I can't say definitively why the CPUs in the small form factor rig are considerably down compared to the test bench. Unfortunately, I just can't pin it on the CPU itself or the cooling solution. It might be a mixture of everything, and that's kind of the downside of testing it with completely different hardware. So here is the place where it's like, oh, okay, well, it kind of has a harder time keeping those average frame rates. And that is it for charts. Man, I had fun going over all of this testing. It was kind of like just a kid in a candy shop to kind of be like, ooh, what can I do here? What can I do here? How is it going to perform over there? So, and most of the results were very surprising as they came in, and it further solidifies the idea of how much I love this chip. And in a small form factor scenario as well, I would have no problem putting it in a situation like this because I know it can keep up. And this is even without testing any of the eco modes or doing any sort of power limiting to make it even cooler. So like the sky's the limit in my mind on how you can kind of configure this out of the box. But that's it. That's all the testing I have for today. So if there's anything you would like to see me test, be sure to leave a comment down below. And while you're down there, be sure to subscribe here on PCWorld for more PC hardware and software goodness. We'll catch you in the next one. Woo, okay. That metal on top says about 130, 131 degrees Fahrenheit. That, oh yeah, that's toasty. I could have a grilled Adam for lunch.